Okay, let's talk about factoring and factoring by the highest common factor, the HCF. Well, we should probably start with talking about what factors are. So factors, pretty simply, are just two or more, making sure you can see that, two or more numbers or variables multiplied together to make a term. It's as simple as that. That's what factors are. And I'm sure that you have factored things before. So we could find the factors of 12, for example. The factors of 12 would be any two numbers multiplied together to make 12. So we could have 1 and 12, 3 and 4, 2 and 6. Interestingly enough, factors always sort of turn up in pairs. There's always a pair of factors, right? And that doesn't change this idea of pairs of factors for our variables either, the way that variables work. So let's have a look at this next one here, this y to the power of 5. Well, there's pairs of factors for this as well. So we were looking for, again, any two variables, in this case, multiplied together that will give us y to the power of 5. So this will be the first one. We've got y times y to the power of 4. Well, that'll give us y to the power of 5. Just to make sure that you remember that, we're talking about our index laws here. So if we've got y and we're multiplying it by y to the power of 4, we can just add the indexes. What's the index on this one? Well, if there's no index written, we understand that to be a 1. And we can just do y, and then you add the indexes together, which will give us y to the power of 5. So any two will give us our pair. Okay, so the other pairs for the y to the power of 5, our factors are y to the power of 2, y to the power of 3, and y to the power of 5 multiplied by 1, because any number or variable can have 1 as a factor. Okay, so we've got a good idea of factors and what factors are. Now let's bring in the next idea. The next idea is the idea of working towards our HCF, our highest common factors, is the idea of this, a common factor. So that's probably pretty easy, this idea of common factors. A common factor is when we're looking at pairs of numbers, two different numbers, we're looking for the factors that are in both of them. Okay, so let's have a look at these first two. We've got 16 and 28. So what sort of numbers would we expect to see as common factors? Okay, well, we can think about that. We probably will find that it's even. It's probably an even number. But we've got to list them all out. We've got to list all of our factors for each of these, which I have done right here. Now, interestingly enough, you'll see that there's not a pair. Oop, moved a bit. Didn't want that. There we go. There's a pair here, 1 and 16, 2 and 8, but then there's just a 4 by itself. Why is that not a pair? Well, the reason why that's not a pair is because 16 is actually a squared number. So 4 by 4, 4 multiplied by 4, is actually one of the factors of 16. And I'm not going to write 4 and 4. That doesn't make a lot of sense. So I'm just going to write 4. All right, and 28, we've got 1 and 28, 2 and 14, 4 and 7. They're all of the different factors. Okay, that makes sense. So what is the common factors? Well, the common factors are any factors that they share, they have in common. So I could have a 1 and a 1, I've got a 2 and a 2, and a 4 and a 4. So yeah, we were right, it was an even. So we can see there that there are common factors between these two numbers, okay, which is important thing to have. Let's have a look then at how it might work in terms of our x values or our unknowns. We would again write all of our different values. Oh, please note that you always put the numbers first when you're listing factors of a number, and it has variables. It has some sort of pronumeral. So we have here for 15 all of the different factors. We've got 1 and 15, 3 and 5. That's all there is. And then we have all the factors of x to the power of 4. So we've got basically every value of the indice up till the value of our original one. This is x to the power of 1, x to the power of 2, x to the power of 3, and x to the power of 4. They're all factors of x to the power of 4. Same for 9. We've got 1, 9, and just a single 3, because 9 is a square number. And we have x and x to the power of 2. So again, if we're looking for common factors, well, we've got the 1s, and we have the 3s, we have x, and we have x squared. So they're all of the common factors. So it's probably not a huge jump then in your thinking to understand that the highest common factor is the one that is the biggest shared factor. Okay, so what might be the highest common factor for 16 and 28? Well, that's pretty obviously this 4. They share a 4 in common, and it's the highest, it's the biggest number, right? It's the highest number. What about for our 15x to the power of 4 and our 9x squared? Well, this one, well, obviously there will be a 3, but there will also be an x squared. So really, our highest common factor for these particular ones, and in fact I think I've got it written down here so it didn't get too messy. I've got the same numbers. So here I'm going to circle them again. It'll be the 3, it'll be the x squared, and so the highest common factor will be 3x squared. Okay, so your highest common factor can indeed have coefficients and pronumerals. It can have all of the parts of a term. All right, well, let's do another really quick one, and this will probably be our last example because they're always the same. It's the same process. You list all the factors, you find the highest common factor, even if it's pronumerals or coefficients, and the things that you have circled, just like I've got there in blue, that is your highest common factor. All right, so let's have a look at these two numbers here. I've got 13 and 11. 13 and 11, let's see, the factors of 13 and 11 are 13 and 11 and 1s. That's it. There's nothing else there. So when I go to write the highest common factor, what do I write? Well, they do share a 1. So is the highest common factor of 1, is that a thing? Well, it is. It's the highest common factor. But what we would call 13 and 11, or any two numbers, is a special term. We would call them coprime or relatively prime. I don't mind relatively prime because the relative kind of makes me think of the relationship between the two numbers, and they are both prime when you look at the factors. What that means is that those two numbers will only ever have 1 as their common factor. The highest common factor will be a 1. So any two numbers that have the highest common factor of 1 are coprime. So we had, let's see, 7 and 9. Well, they are coprime. They're the only. What about 2 and 3? Again, they're coprime. They don't have any other factors that they share except for 1. So it's important as we go forward looking at factors that you know about that idea, about that coprime. Okay? So that's factoring. Finding factors, the highest common factor. Pretty simple stuff.